Now we are starting the new unit, that is properties of bulk matter, in which we are going to study about solids and liquids and their various physical properties. Now if we are talking about solids, there could be n number of different physical classifications which we can talk about, but this chapter is actually inclined toward one topic which is called elasticity. Alright, so what exactly is elasticity? I'll explain you this term, but before explaining this term, let's see how solids are. Okay, what is the basic difference between solid, liquid and gas? These are basically three states of matter. The basic difference is arrangement of molecules or atoms of which that solid is composed of, right? This is what we all know. So suppose, why did I say that the arrangement of atoms? Because there is very orderly and fashioned way of arranged atoms in solids, and that is what it gives its structure, that is what it gives its luster and other thing, various physical properties. Mostly its inability to move or flow, because the bonds are there. Which bonds? The strong molecular or interatomic bonds of solids, right? Suppose these are those bonds which is comprising this solid. So I've made up these 4 plus 4, 8 atoms. Consider it atom, consider it molecule, doesn't matter. All I'm interested in showing you guys is, if these are the atoms or molecules of a particular solid, let it be X solid, these are the bonds which are interacting, like which are within interacting atoms or molecules, and these are the bonds which are responsible to hold solid together in its position. That is why solids have an inability to move, whereas liquids and gases flow. So these are the strong bonds which differentiate solids from liquid and gas. They are right. This is the physical property which we already know. Now, to understand that term elasticity, let us consider that these interatomic bonds or forces are actually elastic in nature. Consider them to be of spring, like these are made up of small springs with which we play or we see in between pens. Okay, so now we are all familiar with springs, right? What are these? Springs are those round, not round, I should say, these are coiled metallic wires which regain its shape when it is compressed or decompressed, or when it is stretched, right? Not if you cross the limit, of course. So now if I try to deform this solid structure, if I press it or if I stretch it, I do anything with this, these spring type structure which are right now what representing the bonds of interaction between the solid atoms and molecules, they will try to regain the position of, or regain the actual position of atoms and molecules as it was initial. So what exactly they are doing? The whole process is inclined towards one thing, that the solid is trying to regain its original shape and size. This is what this term means. Elasticity, it is the ability of a body to regain its original shape and size after the removal of deforming force. Why this last part is necessary? Because unless and until there is no deforming force, okay, what is a deforming force? A force which is trying to change the shape or what? State of a solid, not state. The deforming force, it is deforming. The name itself suggests that. Deforming force is the force which is trying to change the shape of a solid, right? So elasticity, I'll repeat that again for you. It is that property of a body due to which the body regains its original shape and size, right? So if now you know the value of the definition of elasticity and what exactly it means, let's learn some basic terms which you are going to study in this chapter. First of all, okay, I'll write it down for you. One is elasticity, then deforming force, then perfectly elastic bodies, and then perfectly plastic body. These are the 4 basic terms which you should know before we start further topics of the chapter. First one is elasticity. As we just discussed, it is the ability of a body to regain its original shape and size after the removal of deforming force. So what is deforming force? It is an external force or internal sometimes. It is an external or internal force which tries, or you can say which tends to, or which just changes the shape and size of a solid. Then perfectly elastic body. when the elasticity is involved with the solid, let's say this marker, if I try to break it down, suppose even if I'm successful in twisting this by a small angle, it won't regain its size, right, or shape. That is, it doesn't has this property of elasticity, right? Consider the small ruler or scale which you carry in your geometry box. If you bend that scale a bit little, like for a very small angle, it will again come back to its original shape and size, or you can say it regains its original shape and size. So that means that particular plastic or that particular substance or solid is having this property called elasticity. Now we are talking about perfectly elastic bodies. These are those bodies which completely regains their original shape and size after the removal of deforming force, right? And perfectly plastic means perfectly plastic. Plasticity is another term associated with elasticity. It's vice versa, which is called plasticity. Now plasticity means the inability. That means the body is not going to regain its shape and size after the removal of deforming force. For example, clay. You take a clay, you bend it, you stretch it, you twist it, you do whatever with the clay. Clay doesn't come back to original cubic structure or whatever structure the clay we buy it from the shop, right? So plasticity is the inability of a body to regain its original shape and size, and that is where perfectly plastic body comes into play. Perfectly plastic bodies are which do not, or which not at all tries to come back even to its original shape and size, that are called perfectly plastic bodies. So now since we are familiar with these four terms, let's proceed further to the most important topic of this chapter, which is called stress. Now with stress, I do not mean the term which you take during your exams. No, this is the stress. That means, I'll give you the basic formula first, then I'll explain. This means force per unit area. And this is the same formula, pressure also, right? Force upon area. Now let's understand stress. Suppose this is a body. Suppose it is under the action of a deforming force. What can the deforming force do with this structure? It's a cubical structure. It could be a hydraulic press which can press it up. It could be some slide wise. Suppose I hit this solid with a bat or slugger. It will break from the between, right? Anything can happen according to the what type of force it has been acted upon. So when a force is acted on a solid body, the molecules or atoms of that body initially shift from original position to some other position, right? Then due to the interatomic forces of attraction, interatomic, or you can call intermolecular, because in solids it's usually molecules which are in contact with each other. So due to interatomic or intermolecular forces, those particles or those everything which has moved from initial phase, they are going to come back to its original shape or size or original positions, right? Shifted atoms are coming back to original place because of the attractions from the other or surrounding atoms. That is the same thing which you are talking about is elasticity, right? Now when this process is happening, what we can see is due to application of an external force, internal force got developed inside the body, which is pulling those atoms or molecules back on their mean position or back on their original position, right? So that is where stress comes into play. This is called stress. Stress is the regaining force, right? The internally developed force which is trying to bring the position of, or which is trying to bring the atoms back to their atoms or molecule back to their original position. So what type of force would it be? It will be a what type of attractive force, or it is a force which is developed internally in this body. So internal force, right, upon per unit area, upon area. That means because we have to calculate this value in per unit area of the body. We're not talking about the whole body upon whole area, right? So this is a formula of stress. Now when the force is acting, and even if the body is not body is unable to bring back itself into its original shape or size, that means it has been permanently deformed, right? Even that, the force which was responsible for the breaking of those bonds is the force which has caused the stress in the body, and that is why when you'll go to higher classes, you will study about the stress, that before this thing breaks up into two parts or anything happen, there is a stress crack which develops inside the body, and from that crack the body starts splitting up into fragments or parts. So this force could be internal or external upon area. So this is what stress is. So what is the SI unit of stress? Obviously it would be Newton per meter square, but we already know that Newton per meter square is known as pascals, right? So because this is the SI unit of pressure. So stress is force per into area, SI unit would be Newton per meter square or pascals, and the dimensional formula of stress would be what? Force upon area. Force is what? MLT minus 2, area is L square, we get M, L minus 1, T minus 2, right? This L1 minus 2 becomes minus 1. So ML minus 1, T minus 2, this is the this is the dimensional formula of stress. Let's move on to various types of stress according to the point of application or according to the way of application of force.